So write the Maxwell's equation for a linear dielectric conducting medium, and so that any initial free volume charge dissipates in a characteristic time. Okay. So here for linear conducting medium, we have some uh, charge density rho and also current density J. Okay. So therefore, and also a permittivity epsilon, then we can say that D is basically epsilon naught into E. Okay. And B is basically mu naught into H, and also J equals to sigma E from Ohm's law. Okay. Now the Maxwell's equations are, so equation 1 basically divergence D equals to rho, equation 2 divergence B equals to 0 or divergence H equals to 0. You can write divergence H equals to 0. And third one, curl E equals to minus del B del T. Okay. And fourth one is basically curl B equals to mu naught times uh, mu naught times J J plus epsilon naught del E by del T. We can write this also in terms of H, that is curl H is nothing but here is mu naught, so mu naught both sides are cancelled, then we get J as a sigma times E plus uh, del D del T. Okay. So so this is the expression here basically. So we deal about a medium with a permittivity epsilon. So we have to write here epsilon, not epsilon naught. It is for free medium. So here epsilon times del E del T. Okay. Okay. Now uh, we have to show the initial free volume charge dissipates in a characteristic time. Okay. So we have the fourth Maxwell's equation, that is basically curl H equals to sigma E plus del D del T. So take the divergence both side. So divergence of curl H equals to divergence of sigma E plus del D del T. Okay. And next so divergence of curl of any vector field will be 0. So here divergence of sigma E plus del T of divergence D here. Okay, divergence D here. So again we can write that will be 0. We can write this as divergence D is nothing but D is basically what? D is epsilon times E, so we can replace D by in terms of E. So divergence sigma E plus del T of this is basically epsilon into divergence E. Okay. So divergence E in both side. So again we get divergence E, basically divergence E, or basically this is divergence D, that is basically rho, or this is epsilon naught into divergence E, basically rho. Okay. So we can replace this, that is divergence rho here plus del rho by del T is here. Okay. Del rho by del T is here. So from here so sorry, this is only rho, so this is only rho. From here we can rearrange these things, that is del rho by rho equals to minus del T, then integrate both side, we get ln rho equals to minus T plus some constant here C. So from here we can write it as rho equals to I think I make a mistake here. Okay, I make a mistake here. that is divergence E equals to rho by epsilon. So from here we can get this is rho divergence E equals to rho by epsilon. So we have to write here that is sigma by epsilon. Okay, so here sigma by epsilon. So after that we get that is del rho by rho uh, equals to minus epsilon by sigma into dt. So integrate both side. So here ln rho we get, and from here we get epsilon by sigma into t plus some constant like say a. Okay, so after that rho is nothing but some constant is here. If we take exponential, then constant c times this is exponential of e to the power minus epsilon by sigma into t. Okay, so from here if we put t is 0, we get the constant value c. If we put t is 0, then we get c is nothing but some rho 0. Okay, so therefore we get the actual relation rho equals to rho naught e to the power minus epsilon by sigma into t. Here we can replace epsilon by sigma as e to the power minus t by tau. So where tau is basically defined as sigma by epsilon, so this is called the relaxation time. This is called basically characteristic time. Okay, so this is the characteristic time. So this is so initial volume. So initial volume charge dissipate in a characteristic time. So here the initial charge dissipated on the basis of this equation. Okay, so that is tau, that is epsilon by sigma. Sorry, tau will be epsilon by uh, I think epsilon by sigma. Okay, epsilon by sigma. Tau is basically here epsilon by sigma. So it will be sigma by epsilon, because here we get sigma by epsilon, sigma by epsilon. Okay, sigma by epsilon, sigma by epsilon. So here we get sigma by epsilon. So tau will be epsilon by sigma. So epsilon by sigma is called the relaxation time. That is the free charges decay exponentially with a time constant that is called tau, that is epsilon by sigma, placed in a medium of conductivity sigma as well as permittivity epsilon. Okay,